Welcome back, factory owners, to this mini-series where I want to show you how I tackle a complex design process like the one of my Gatoino Cat Laser Toy. You find a lot of bits and pieces on YouTube, but none of them are really comprehensive. Now join me on the first part where I show you how I designed the laser assembly. For my first mirror prototype contraption, the basic shape was already clear. You see, there are many holes that I used to test out how far I need to space out that mirrors. Turned out, they work best when they are spaced apart as closely as possible. From there I sketched out this very basic shape that consists of nothing more than a few rectangles and holes to mount the mirrors. In the next step I already added those mirrors, and you can see in the small lower mirror it has holes on both sides, since I derived that design from the initial prototype and didn't check that I don't need that second hole. To get a better feeling for the physical space I need, I downloaded the servos model from Thingiverse and added it to the design. In this first iteration I just placed them somewhere and they are still clipping inside the body. And by the way, the extrude tool alone is already accounting for 90% of this design. The rest are holes and a few chamfers. To see how far I need to space everything out, I started to add the gears. For that I used a tool called GF Gear Generator. You only need to input a few parameters and it will create the whole gear for you. The only thing I still needed to add was the hole to fit the gear onto the servo. For the mirror axis I added hex connectors so I can print the gears and the mirror axis both separately, and that means I can print it flat on the print bed without the need of any support material. I was aiming for a 1:3 gear ratio from the servo to the mirror axis. With that I can make the choppy movement of the servo, well, a bit less choppy. Having the gear on the mirror axis a bit larger than 3 times the one on the servo is also no problem. The main goal was that the two are meshing and move smoothly. You can see that the gear on the mirror axis is still colliding with the initial sketch of the frame, but that's a problem to solve later. I added a few more rectangles to the base sketch to have a mounting point for the servo. You can see it is still consisting only of rectangles and a few extrusions. From the motion simulation you can now see how far the mirror can move. I limited the movement of the servo to 180 degrees like it is in reality, and you can see that the mirror is already moving far enough. In the next step I added a second mounting point for the servo and also made sure that there is enough clearance for the cable. You can see I opted to mount the servo screws on one side from the front and the other from the back, because that is what fits best to this design. For the second servo I used the same gear that I added for the first servo, since I wasn't sure how to proceed from here. In the final design that gear is quite a bit larger to fit into the overall design. I knew that I needed a partial gear in order to save space, but I didn't know how that would work out, so I made a very crude prototype and inserted it just to see how it fits. You see that partial gear doesn't meet up with the servo where the other gear does, so I had two options, making the gear on the servo larger or making the partial gear larger. I opted to change the partial gear. Now the gear generator only makes whole gears, so I needed to cut a few things away to get a partial gear. I opted to also make it a bit thicker and then cut out a part of the body in order to have it a bit offset from the center point of the servo. I also added markings on the gear and the mirror axis to indicate how that thing needs to be put on. In order to make my design work, the gear on the servo needed to be larger than the base of the servo to avoid collision. You also see that I switched the servo around 180 degrees to be closer to that partial gear. From the motion simulation you can see that the range of movement is still plenty with this setup. In this step I also added a hole for the laser diode and created a distinct shape that the laser cage has on each sides. The reason for that distinct shape is that I added a frame inside the case where you can easily put in that laser cage without having to screw it in. It will simply stay in place because the case is closed and screwed in on both sides. Now with the motion system working, I needed a place to screw in that second servo on both sides. And I also made sure that the gear for the small lower servo was movable and removed that one part of the frame that was in the way. With those holders for the second servo, that whole cage got a lot more rigid. The front part of that servo holder is chamfered to not interfere with the laser light, and also because it looks better. For the new partial gear design I also needed to cut out a small piece of the laser cage in order to make it fit through. To not have the screws of the mirror axis stick out, I also added a counter board to all of them. But I will also later remove the one for the small mirror axis for reasons I will explain later. At this stage the base design already worked pretty good, but there were still a few details I needed to work out in order to make it work perfectly. I added an additional piece of framing on the side of the lower axis mirror to make the laser cage a bit more rigid. The frame design as it is serves two purposes. One is making the laser cage as rigid as possible, but the other one is also to keep the servo cables from coming in contact with the moving gears. Now the gear design works in principle, but the teeth are also rather fine, which makes them hard to print. Now in order to make them printable easily, I reduced the number of teeth to the minimum amount possible while still maintaining full functionality. You can also see that through of the gear's positions, they didn't mesh correctly anymore. Since I had a few other issues in that file, I created a new one and did only the steps that I really needed and omitted the other ones that were made along the way to have a fresh start. In that step I also removed the counter bore for the small lower mirror because it either was too small and created friction, or it was too large and therefore had very flimsy walls, and there wasn't really any physical need for that hole. While I was building one of the first prototypes, I noticed a few small things that needed to change. For once, the small lower mirror was mounted to a block, and this block could collide with the hex mounting point of the gear. So I needed to make that block a bit larger in order to make it not collide with that block. The other one is that the laser was visible from the side, so I made the laser housing a bit longer in order to mitigate that problem. I also added a small channel in order to route the cable of the laser diode easily. I also needed to adjust the laser's position a bit to prevent refraction of the laser light from the side of the mirror's glass. Since the laser was still visible from the side, I extended the housing yet a bit more. I also added a 45-degree angle to the hole to make it easily printable when flat on the bed. While working on a general design overall, I was also constantly working on all the tolerances. Those are very important to make everything fit together properly. I also added a few fillets and chamfers here and there for the professional look overall. If you want to get into 3D design as well and don't know where to start, check out my Fusion 360 Fundamentals course. The first chapter is free with a link in the description. And also check out my Gatoino Cat Laser Toy. It's a great way to support the channel. Stay tuned for the next part where I explain how I integrated the electronics. See you in the next one.